All right, good morning. Our next unit is going to be all about areas of different figures and different parts of those figures. And then after that, we'll move into surface area and volume, which is when we'll look at 3D shapes. So we're going to focus on these two-dimensional objects first. All right, so today we are going to focus on parallelograms and triangles. So many of these formulas you guys probably remember. Like the area of a rectangle is, we're gonna start calling it like base times height instead of length times width, only because that'll make it easier when we get to surface area and volume. The area of a parallelogram is actually the same as the area of a rectangle. But what you have to remember about any height, regardless of what shape you're talking about, is that the height and the base must be perpendicular. And that's what that symbol means, perpendicular. And so when we're looking at like a rectangle, that means that any of these can be technically the height, even though we usually think of it as the straight up and down. But when we're looking at a parallelogram, it has to be this 90-degree angle. We have to be looking for that. So this right here, that like slanted side, is not the height. It's not the height. Same thing with a triangle. The area of a triangle is 1/2 of the base times the height. And the reason for that is if we think about a rectangle, if the formula for the area is base times height, we can cut that rectangle into two triangles. And so the area of that triangle is half of the area of the rectangle. So that's where that 1/2 comes from if you've never known that before. But the height is the same thing. It's got to be the perpendicular part of the triangle. Okay. All right, so what we're going to do in this first example, it says find the area of the non-shaded region. So I want all this white space up here. And so I know that the area of this shaded rectangle is 6 times 4, which is 24. And so whatever I get for this big area, I'm going to have to subtract 24 from that. So what I want to do is think about how I could break this into several rectangles. So I kind of see taking this straight across here and taking this straight across here. And so now if I could find the area of this rectangle, and this rectangle, I can add all those together and then I can take away that 24. All right, so this rectangle right here, I know the height is 2 centimeters and length of the base is 22. So 2 times 22 is going to be 44. Now we have to figure out this rectangle. And I know that this is 6, so it's going to be 6 times something. So I know that that whole side is 22, and then I know from here to here is 8, and so that means that if I take 22 minus 8, I'm going to get 14. So that's going to be that top and bottom part. And so 6 times 14 would give me 84. And then this last part right here, I know that height is 10, and then this base, I still needed that 14 for. So 23 plus 14 is going to be 37. We write that up here so I don't crowd it. And so then 37 times 10 is going to be 370. All right, so when I add all those together, the area would be then 370 plus 84 plus 44. Right, those are the areas of the three rectangles, but I have to subtract that shaded region. And so I'm going to get 474. And then the units for area will always be whatever your units are, so centimeters, inches, feet, whatever, to the second power. Right. And the reason for that is I'll use this like shaded rectangle to illustrate that. So we're really taking 6 centimeters times 4 centimeters. And so when you multiply centimeters by centimeters, you get centimeters squared. And so area will always, always, always be in units squared. Just like anything, it's super important that you do include those units. Okay. All right. So now we're just going to practice kind of identifying the altitude. Remember, the altitude is essentially what the height is. The altitude is a segment that's drawn from a vertex of your figure perpendicular to the opposite side. So in a parallelogram, we're usually going to be looking for the height in a couple different places. Either drawn from one of the vertices straight down to the other side like that. And you could do that here too. Or we may be looking outside of our parallelogram. So we may be looking for that kind of like extension piece right there. And again, we could do that on the other side too. And then the triangle is kind of the same thing. So I'm going to draw it maybe from a not like conventional vertex. Like most of us would probably just go straight down there. But maybe I'll do one kind of coming from this vertex. I know that may not look like it, but pretend. Or I might be looking for it like outside of the triangle. And again, you can draw the altitude from any vertex. It really just kind of depends on what measures you're given, where they're located, etc. All right, so now we're just going to do a bunch of examples, just making sure we can identify all of these pieces correctly. All right, so we're looking first at a parallelogram. The area of a parallelogram is always the length of the base times the height. And so here, the 5 inches, that's going to be the base. That's what the figure is sitting on. And then the height, that's the perpendicular segment. So that would be the height. So that means the area is going to be 4 times 5, which is 20. And then our units would be in inches squared. All right, so for this one, here's my parallelogram. So I've got that this is 2 centimeters. This is 4.6. So I need the height. I've got the base, that's my 2. And so that is what that 3.5 is. It's that perpendicular segment, the altitude from the vertex, perpendicular to the opposite side. So we kind of extended that over. So the area of this parallelogram then would be 2 times 3.5, which would be 7 centimeters squared. All right, so now we're going to be not necessarily finding the area, but using the area to find one of the other parts of the parallelogram. In this case, we're looking for the height. And we know that the formula for the area is base times height. So if I know the area is 24, the base is 6, not the 5. The base of the parallelogram is always going to be the side that it's sitting on. So I plug in 6. The height is what I don't know. And so now if I have to solve for the height here, I would just divide both sides by 6. And I would get the height is 4. No, there's no units in this particular parallelogram. If there were though, like inches, centimeters, whatever, you would not put the squared part because you're not looking for the area, you're looking for one of the parts of parallelogram. All right. Oops. All right, so now we're looking at kind of a more complex picture here. So it says find the area of ABCD, so this parallelogram right here, and then find DE, which is the height, to the nearest tenth. And it does tell us that FC is one of the heights. So if you kind of turn your picture this way, instead, remember the height is always drawn from the vertex perpendicular to the opposite side. Okay, so in this case, when we would turn our parallelogram like this, AD would become the base. So again, you don't necessarily have to, like if we were looking at our parallelogram like this, we would want to use this as the base, and then the height would be the longer part. But if we turn our parallelogram this way so that we can use this other height right here, then this becomes the base. So it all depends on what you're given in the orientation of your parallelogram. So that's why I put that right here. So 9 times 13 is 117 inches squared. So now if I want to find this other height, the longer one, using the shorter base, I can do just what I did on the front. So again, I know the area is the base times the height. So the area of the parallelogram is always still going to be 117 inches squared. It doesn't matter like what parts you're using. And so then this time the base would be 9.4, and I'm looking for that other height. DE. So if I take 117 and divide it by 9.4, and we were told around to the nearest tenth, so I'm going to say that this is about 12.4 inches. All right, so now this one is kind of the same. It says find H right here. Find this height. So we're going to kind of find the area essentially twice using two different heights. So first of all, because this is a parallelogram, I know that if this is 3.8, I know that other side is 3.8. And so if I turn my picture this way, now I can use this base and this height. Right? And so I can find the area of the parallelogram. And so that would be 3.8 times 4, which is 15.2. And so now I can orient my picture, and this 9.5 is supposed to be for this whole thing. It doesn't necessarily look like that. Now I can use my 9.5 as the base, and then use that to find my height. So I'll plug 15.2 in for the area. The base would be 9.5, and now I'm looking for the height. And so that's going to be 1.6. Again, there's no units on this one, so I don't have to worry about that. Okay. So again, you can turn your parallelogram however you need to find what you need. I would not have been able to find H if I had my parallelogram sitting on the long side, because I didn't know the area. But if I turned my parallelogram so now it was sitting on the short side, the height is going to be how tall it is this way. So your base and your height should always be kind of related like that. The side that you're sitting on, how tall it is. The side that you're sitting on, how tall it is. Those are the parts that go together. So again, kind of in a parallelogram, you'll always have like the longer side goes with the shorter height, the shorter base this way would go with the taller height. All right, so now we will look at some triangles here. And so what we have to do here, again, the area of all triangles is 1/2 times the base times the height, because a triangle is always half of a rectangle or half of a parallelogram, depending on how you want to look at it. And so what I need to do, the height is always drawn perpendicular to the base. So if this is the height I know, this is the base that I need. This whole thing. Well, right now, I only know this part. So I need to be able to figure out this part in order to find the length of this entire base. Because I also would not have enough information. I could not draw another altitude in because I still just wouldn't know enough information. Like from here to here, I wouldn't know how long that altitude is. So I wouldn't be able to do that even because I don't know the area. So here's where we're going to pull in some information from last unit. Because we know that the altitude is drawn perpendicular to the opposite side, we've created 2 right triangles within our big triangle. And so if I know that the hypotenuse is 9.2 and I know one of those legs is 7, I can use the Pythagorean theorem to find this other one. So I'll set that up. So I'll do x squared plus 7 squared equals 9.2 squared. So 7 squared, is 49. 9.2 squared is 84.64. And when I subtract 49 from that, I get 35.64. And then when I take the square root of that, I get x to be about, we will just round that to 6. Because that, even if I round it to the nearest thousandth, we'll bump that up to 0.97. So that'll be close enough. We'll call this about 6. So keeping in mind that we're not necessarily giving an exact area here, we're going to have to approximate this one. So if this is 6, that means the length of the base is 16, and then our height is 7. So our area would be 1/2. Times that. We can just type that all in. 1/2 times 16 times 7 is going to be 56 inches squared. So now this one's going to be a little bit easier because we don't have anything we need to find first. And so I am looking for this right angle here. Remember, the base and the height should always be perpendicular. So you can either look at your triangle like that, or like that, right? Because we're always going to be multiplying these two. Those are going to be the base and the height no matter what. And so since you can multiply in any order, it does not matter which one you call the base and which one you call the height, because you're taking half of that product anyway. So this one's going to be a little bit nicer. 1/2 times 3 times 4, half of 12 is going to be 6. To the area of that triangle, 6. All right, and so now in this one, the base is 11, because remember these like dashed lines, this right here is not part of the base. It's just kind of that extension so that I can get that altitude drawn in. And so my area would be 1/2 times the base, which is 11, times the height, which is 2.5. Okay, and so and I get 13.75 feet squared. Okay. All right, last problem, and then we are done until after spring break. Well-deserved 2-week break here coming up. All right, so now we're given that the area of a triangle is 100 inches squared. The ratio of the base to the height is 2 to 4. Find the length of the base and the height. All right, so here we're going back to ratios and proportions. And so remember when we do this, if our ratio is 2 to 4, we have some like scale factor, some common factor that we don't know. So I am going to say that the base is 2 times that factor that I don't know, so 2x. And then the height is 4x. Remember we did that with, like when I said the ratio of angles in a triangle is 3 to 4 to 5. We did like 3x plus 4x plus 5x equals 180. And so what we're going to do now is the same thing. We need to figure out what that like scale factor is. And that will help us find the base and the height. So if the area is 1/2 times the base times the height. Then if we multiply just our coefficients together, so 1/2 times 2 times 4 is going to be 4. And here we have to be careful with our x's. So if we have x times x, that's going to give us x squared. And then we know our area is 100. So if I need to solve for that x, right now it's being multiplied by 4. I need to divide by 4 first. So I'll get 25 equals x squared. And so that means technically x, when we solve algebraically, we're thinking what number to the second power is 25. So algebraically, our answer should be positive or negative 5. But since we're talking about lengths here, we cannot have a negative answer. So that's why we just keep 5 as that factor. And so now I take that 5 and I just come back up here and plug that factor. Oops, it should be a 4. Back in. And again, we know that the base is the 2x and the height is the 4x because that's how the ratio is presented. Base to height, 2 to 4. So the base is the 2 and the height is the 4. So that means the base is going to be 10 inches and the height is going to be 20 inches. And that's 2 to 4. When we simplify that, that's 1 to 2. And that would be 1 to 2. Okay. All right, so I am not giving you guys a specific homework assignment over this stuff. I want you guys to make sure you enjoy these 2 weeks off without having anything to do. What you do need to make sure you do is go in Canvas and Power School. Make sure that you're not missing anything. Anything that is more than 3 days late, you can still turn in for half credit. Anything that's less than 3 days late, you can still turn in for full credit. Anything that you got less than a 5 out of 5 of for like being wrong, or if you were forgetting a couple problems, go back and fix those, resubmit it, and I will change your grade. Okay. There is also a survey that I posted on the homepage that I would like for you guys to fill out. Just give some kind of feedback so that I can best plan for the next 3 weeks of e-learning and enjoy your time off, guys.